Okay, this is the Prehistory to Digital Libraries video. As you can see here, it's linked on the syllabus, but I have not completed it yet, so I don't have minutes for it, but I will post that very soon. I do have the PowerPoint presentation that we're going to look at posted here, and we can open that up and start that. So this is an introductory presentation to the really what we're going to be talking about through most of the course, but a lot of prehistory. In this presentation, I really see this as just sort of us getting into the shallow end of the digital libraries pool, if you will, so we can kind of become familiar with some of the precedents to the digital library world or the history of it, and some of its influences, precedents, players, technology, so on and so forth. So what is a digital library? Well, there's going to be multiple definitions, and I don't know that there really is one correct one, but we're going to look at several in this presentation, but we'll also look at some in our readings that are going to be assigned for next week. So what Roy Tennant, he's a I would say, you know, kind of a superhero in the library world. How he defines it as anyone, anywhere will be able to easily locate and use any text, image, database, or other type of digital resource. Often sophisticated ways, that's sort of a key term there because that's a new thing, and be able to associate it to related objects. And so his idea is it's not only digital information, but it's also things you can do something with it more than just merely reading it. And his idea, and you could say this, it's kind of common sense, but all you need is access to the internet. Technically, you could do a digital library on a CD-ROM, but we're only, other than this week, we're really not going to talk about that because it's already kind of outmoded technology. Here we have another definition. A digital library, also, it's a little bit redundant here, referred to as a digital library, is a special library with a focused collection of digital objects that can include, again, text, visual material, audio, video, stored as electronic media formats as opposed to print, microform, or other media, along with means of organizing storage, retrieving the files contained in the library collection. Now, sometimes you'll hear the word electronic media, and this is already kind of getting into something kind of technical right off the bat, but the difference between digital and electromagnetic are different, or electronic. So for example, you could have a videotape that's electronic, but it's not digital. So we'll talk about that a little later on, but basically digital is what we're always referring to, something that entails using zeros and ones to render the information. Here we have another, what is a digital library? Digital libraries are organizations that provide the resources, including the specialized staff to select, structure, offer intellectual access to, interpret, distribute, preserve the integrity of, and ensure the persistence over time of collections of digital works so that they are readily and economically available for use by a defined community or set of communities. I really like this definition, very comprehensive, a little bit broad and generic, but I like it nonetheless. And so here's just some ideas of like, why do we want digital libraries? Some of you may be taking the course with really no concept of what one is. We probably have all used one at one time or another, but know that obviously digital is in the name, so it must be the future. We're not going to you know, look at the future as a place for analog libraries, although they will be around. They're not going anywhere. But anyway, so why a digital library? Well, it brings access to users in a very easy, obviously very fast way. Always available, better, wider delivery. All of a sudden you have many libraries that are right at your fingertips. Sharing information resources and linking, that you can do things in a digital library world that you just can't do as easily, or sometimes you can't do at all in a print-based library. It's fast, that's another one. Some of these are kind of no-brainers, but nice to sort of sum up on a page so you get quick, very timely access to information. There's ways that you can search information once it's you know, a digital library in ways you can't with a print-based collection. new forms of information resources that are possible that you just wouldn't have in a print-based one, or if you did have it, it would be so cumbersome it wouldn't be worth using. all sorts of new services that librarians can provide to their users via digital library. Costs, that's something we'll talk about later in the course, but you may save effort and money. I don't know, it's an open question. So, it's very cheap. Computing has become very inexpensive now. Sometimes something that you can create some information now very cheaply, but to preserve it, say, over time for 10, 20, 30 years, maybe it's not as cheap as it was with the print-based world, but we'll talk more about that as we go along. So what are the precedents, what preceded the digital library, and ways we can kind of learn about how it's evolved and, might tell us where it's going. Well, it came about various needs, ideas, technologies, and standards, so it wasn't just the library world that invented the digital library. There's a lot of different players, businesses, academic disciplines, again, some of it being developed by librarians themselves. Other times there are other technologies and technologists that were influencing its evolution. Some of the events that took place that allowed for digital libraries to come about happened sequentially, sometimes concurrently, and sometimes they just seem to kind of come out of left field, like they just didn't even know that this invention was going to come along, and then here it was, and they thought, oh, well, we can use this for digital library work. And some of it was just kind of luck, that discoveries or inventions or technologies that they took one from one field and took one from another and put them together, and lo and behold, we had something that was really unique and helped us build digital library technology. So it's 2017. The future is here. Well, some people would say it is, other people wouldn't. I would say that the future, in a way, is not here, because I've seen a lot of the sort of predictions and promises not really come true, and some of them did. And so there's some things that they never even knew, as I said, came out of left field that no one predicted, and it just kind of came out of the ether. But so science fiction says it's supposed to be the future. Well, 1984, well, we've already passed that a long time ago. Some of that sadly come true in that book, and other things not so much. Blade Runner set in 2019, so maybe the driverless car and the robots and so forth, we still have another 2 years to get all that in place, so maybe some of that will happen. 2001, again, we've already passed that. A lot of that is still sort of waiting to happen. Rollerball, more obscure science fiction movie set in 2018. Again, some of the things, that's sort of a near future type dystopian almost science fiction movie. Some of the things have come true and some haven't. But we're still waiting for our space packs to fly around. I know they do exist on YouTube, but how I got here to work was I just got in a car and drove here with a gasoline engine that's been around for now over 100 years. So in some ways we're still waiting for science fiction to happen. Here's some examples of some various computers that precede the computers we use today. I'm just going to pop out of the presentation for a second, but here we have the Enigma machine. If you've ever watched, there are a couple movies and books out there about that, but that was a secret coding and decoding machine that was developed by the German army. The Nazis used it, and it was very sophisticated, and they could send messages, again, using this computational type machine. It was all analog, but it was a computing machine nonetheless. Could encode messages that they considered unbreakable. Well, we'll talk about him shortly, but an English computer scientist, his name's slipping my mind, but we'll come back to him, basically broke the Enigma code, and they thought it was unbreakable, but he broke it actually using computers that he developed himself, and languages and sort of computer logic he invented himself to break it. And so they did break it, and that's what helped the Allies win the war, because then they could start decoding the messages. Here we have a differential analyzer. This is again a mechanical analog computer. So it's not digital. There's no zeros and ones. It's all still using. It's not using electromagnetic impulses that we'd have on our computer. It's using analog, switches and levers to do computing. But you can see how big it is. It takes up a huge room. Here's the first digital computer, and literally, when they say, it took up a whole room, it did, and then some. And this is to do some really, really basic types of calculations. We're not talking about even playing Pong on it, never mind Grand Theft Auto or any kind of video games like that. It was very, very basic. All tubes that was run on, they hadn't yet developed solid state, which is basically like a circuit board. These were tubes that, if you're old enough, like I am, to remember tube TVs, or if you're into music, like tube amplifiers, they had to have tubes, so these things would get very hot. They needed to be cooled. And then we have the ARP synthesizer. That's the first synthesizer used. It was used a lot of computing technology. Basically, it computed music, if you will, synthesized it, but it didn't do it using conventional ways of making music. It sort of computed it. And you had to be very smart to run these. Just as an aside, like the ARP synthesizer was used by The Who. Pete Townsend used one, and you had to actually spend a lot of time to learn it, and pretty smart person, more than a musician, to run them, because they really required a lot of skill. Now you can use a synthesizer and get some sound out of it without very much learning at all. Background to a digital library. This is, I would say, kind of the I don't know what you would call it, kind of a foundational piece in any kind of digital library course you would take, or maybe a history of information technology. They always talk about the Memex machine, which was by Vannevar Bush. He wrote a very famous piece in the Atlantic Monthly that I'm going to have you read, called As We May Think. And basically, let me check my notes out here just for a second. But basically, Bush, what he was tasked to do, he worked for the Army, for the government, was the Army had created so much information. World War II created just millions of pieces of information, new knowledge. Science was taking off like never before, lots of scientific documents. And so basically, the government tasked him is, how do we organize this information and make it so we can access it easily? Because humans can no longer process it all with our eyes and, reading and writing. We need computer assistance. So he wrote an article called As We May Think, and here you can see a picture of what he sort of envisioned of how we would access that at the time. So this is in the sort of mid-40s when he wrote this piece. And at the time, digital didn't exist, and what they had was microfilm. They did have forms of micrographics that were analog, like you might see like spies or people in the war taking photographs with microphotography. Well, that's what these reels are here, and then various buttons to push them. And then these readout screens, I think some of this was sort of still left to the imagination because they really didn't know how they were going to present it. But anyways, he had lots of vision, but not necessarily the means, or the youth to realize some of it. This is an example of, I guess, in a way, of kind of a Memex machine that really did not meet the goals of what Bush set out to do. But here we have a microfilm machine. Perhaps if you all taken the records management course, or maybe archives and manuscripts, or preservation for that matter, you've seen a microfilm machine or read about one. Anyways, they were film-based. You would put on a reel. There'd be frames just like you would have in an analog photography. Here you can see each frame where my cursor is going. And each frame would be perhaps maybe a newspaper or a document, but it was a way to miniaturize information. And so that was kind of one step forward towards the digital library that we know today. And we had microfilm, aperture cards, and microforms as well. So really becoming a thing of the past. At least for the department I work in, there are some places like banks governments or places that really handle material like nuclear warhead material, they might still use microfilm because it does have a shelf life that's decades, if not hundreds of years, if it's stored correctly. But this class is not about microfilm, but just thought I would talk about that. Here we had another great thinker, someone I've talked about in some of the research I've done. His name is George Paik, and he was the co-founder of the Xerox PARC. This was like an institute or sort of like a think tank for Xerox. Xerox obviously is a company. They developed the Xerox photocopier, but lots of great thinkers, inventions came from there. And one of his ideas was this office of the future, is what he coined, and it was this dream of the paperless office. And so the paperless office, in a way, was sort of a continuation of what Vannevar Bush had been working on, and thinkers like Paik and others really thought we were really just months, if not years if not months rather, getting away from all this paper and going to nothing but a computerized environment, which would be, in a way, another name for a digital library. The paperless office, I'll just say this as an aside, is still with us today. I look around my office, I've got paper everywhere, but it is dying. It's a slow death, but it is dying nonetheless. But it's something that they really thought when Xerox, nonetheless, I don't know what they're thinking, because basically they're making all their money from photocopiers that all they do is create paper. But Xerox had some optimists that worked for them, like Paik, who really thought they could basically replace the printed document with a digital document. Here we have another really smart man. He's no longer with us. Many smart women, which we'll talk about as well. But Douglas Engelbart, he's basically not him alone, but he was the leader of his team who created the modern PC as we know it. So I'm holding a mouse, I'm moving this cursor around with a mouse, I'm looking at monitors that have windowing technology. So here we have Windows, we have mouse, and then all the stuff I use to do my work. I use email. Email is still with us. Email has not died yet, even though I think Facebook is and instant message and so forth, and FaceTime's trying to kill it. Email is still with us. Forms of chat, these are all like put under the term groupware, which is kind of a suite of tools called groupware, which is sort of a dying term. If you're of a certain age, you might know it, and if you're maybe under that certain age, you probably have not heard of it before because it's kind of gone out of fashion. Calendaring, this would all be part of like a Microsoft Office suite. Or if you know of another company by Novell, they did something called GroupWise. They did the same thing. They had all sorts of word processing, emailing, chat, and so forth. He invented it all, and when he did that, it was called the mother of all demos. It wasn't called it at the time. It was sort of later on called that because he, in sort of one fell swoop, invented so many technologies and computing software that's what it became called. He sort of co-developed the mouse. He and another guy who actually left and went to Xerox PARC, Engelbart had his own company, went and took that and then refined it and obviously got rid of the wood and went with another computer. And this is at Xerox PARC what we would see is like the sort of what we'd recognize as a conventional PC computer. You have the mouse, you have the right and left, or left and right click, keyboard, monitor, and you can see you have windows and icons. Engelbart and Xerox, between the two, they really brought the modern computer, invented the modern computer. People like Steve Jobs and Wozniak really didn't invent much. They kind of took what they were really good at, seeing great ideas and envisioning how they could be commercialized and brought into the sort of the general public. But Steve Jobs really didn't invent much. Don't quote me on that. He has invented a few things, but a lot of the stuff he did was he was a very good refiner and perfecter of things, but inventing he was not. and Apple for that matter. He kind of came and went from Apple, so he wasn't there for everything. But remember, Xerox PARC, this is really just miles from where Steve Jobs worked and where the Woz worked, and all these guys sort of came and went, saw each other. They were all friends or maybe enemies, but they would see each other all the time. So it was really a rich environment for modern computing. So here, the rise of MARC, what I would see is one of the first big contributions by the library community to the digital library world. Henriette Avram, she's no longer with us, but really probably one of the most important, in my opinion, one of the most important people in library history. She almost single-handedly, she had a team of people who worked with her, but she was the leader. She almost single-handedly invented MARC, which is still with us today, been around since the late 60s, early 70s. And if there's any one invention, in my opinion, that took libraries into the modern era, it would be MARC. The biggest change, biggest advance in libraries in the 20th century, by far. She was not trained as a librarian. She had a computer background, but she went and worked for the Library of Congress, released early versions of MARC in the 60s, and then by the time Yours Truly was launched, MARC had become basically a real standard, and it's still with us today. It's been refined. People, librarians and standards committees keep adding to it, but it's still with us today. So that's something we'll come back to later in the course. But when standards are invented, they're sometimes take a long time to come to life, and then once they do, they don't want to die. They're really hard to get out of, for better or worse. OCLC started out just like as a regional organization. It was something like Ohio Colleges Library Consortium, and then it turned into, and boy, I should know this, but I don't, but basically something like the Online Consortia for Library something. Anyways, OCLC is the biggest library non-for-profit standards developer in this country and in the U.S., but probably perhaps in the whole world. But they developed the Z39.50. If you're going into cataloging, you should know about that, or you will need to learn about that. But basically what that standard did was allowed us to check people's holdings on a computer, either at the library itself, or if you were at home, and this is again pre-World Wide Web, but you could telnet in using a DOS prompt and look at library collections from afar. So again, kind of inching us toward this idea of a digital library. At this point, all we're doing is just looking at essentially an online card catalog, if you will. We're not really searching the actual content itself. We're merely just looking at metadata records or card catalog, if you will. Right along the same time, we have the advent of the ILS, the Integrated Library System. Right now, that's going through a huge sea change in how we look at ILSs. But the ILS has been with us really since the 70s, and that's what helped make the MARC format, facilitated the work we did with MARC and cataloging. Created user interfaces on computers pre-World Wide Web, and then after World Wide Web, what we have today, cataloging. It's a whole, basically, it's a whole suite of tools that catalogers and technical service departments use. It's really the backbone of any library almost. Here we have a picture of a screenshot here of a what you would have seen had you gone online to a public access catalog. Now this is what I used when I first started college. So you're online, but you're not in the World Wide Web. You're basically using a DOS prompt or telnet type environment where it's nothing but key commands. If I were to have a mouse, which my computer did, it has no use. You can't use a mouse when you're using like an ASCII based or text based interface. It is not a graphical user interface. But anyways, this was a precedent for what became a graphical user interface catalog, and then eventually we got to web-based ones. I don't know what else to say about that. They were really fast. Anything that's when you're using a text command or DOS prompts, they're a lot faster than using a mouse. I don't know. There's other things we can say, that positive things, but again, this is just the history of us arriving to the digital library. We'll come back and talk a little bit about this possibly one other time in the course. And then, okay, so other developments, remember, some of them are sequential, some of them are kind of happening at the same time. Another great man here, great inventor, lots of great men and women. I didn't mean to say it that way, but this was someone who was sort of called into service, if you will, to develop a piece of technology. He was actually trained as a lawyer and was just a professor, but he needed a way to mark up documents and send them over the web. So this is, again, pre-World Wide Web, so we're really talking about sending them over the internet, because, again, we're talking about the 1960s. He developed what's called Standard General Markup Language, and that was kind of the mom or dad to XML, which we know about today and we will talk about in this class. There's also a whole class dedicated to learning XML as well. But he did this in sort of right alongside of Mark developing. Mark didn't adopt SGML or XML until many years later. But it was this idea of how do we mark up language, how do we mark up text, digital library. This is just one more step forward for the digital library as we know it today. So Moore's Law, this is something we'll talk about a little bit. It's a favorite topic of mine, but Moore's Law basically, again, is this sort of background idea of like how we have digital libraries today and how we have anything digital. But Gordon Moore was a computer scientist, here he is on the left, who worked for Intel. Intel makes microchips. And basically what he did, this was not a law per se, but more an observation, but it just got coined Moore's Law. But basically, every 18 months roughly, the size of microchips and the speed of them, one will shrink by half roughly, will shrink, and the other part, the speed, will double every 18 months. That's a miraculous claim to make, and basically that has been with us since the 60s. This is like a type of wealth, luxury, if you want to call it, that we've had in the technology world that's just unprecedented. So it's been great news. That's why pretty much for the 60s, 70s, and 80s, but definitely in the 70s and 80s, where we, technologically speaking, we made jumps with leaps and bounds because of Moore's Law. Moore's Law has allowed us to do everything that you can think of when it comes to technology. TVs, why they're so cheap and they're so huge and they look so beautiful to look at today is because of Moore's Law. Solar panels are Moore's Law. Tiny little thumb drives, little computers, your iPhone, digital watches, cars, the Prius. I can just go on and on. This is a little surreal because I could just list many hundreds of things, but it's all because of Moore's Law. And the sort of bittersweet aspect of this, or story about Moore's Law, is that he himself has predicted that it's either dead or it's going to die. And so it's, anyways, if you get some time to look up Moore's Law, it's worth it. You could look it up on the Wikipedia page or maybe watch a YouTube video about it. But Moore's Law is more or less still with us, but for how much longer, I don't think anyone really knows. The internet was developed. We've had the internet for decades now. That was developed by the government. That infrastructure was used basically, as I was saying, there was Telnet, there was Usenet, there were all these online communication platforms you could use, but it was not the World Wide Web as we know it today. It started out as the ARPANET, DARPANET, there's like all these net names, but basically it became the internet, and then it stayed that until the early 90s. And then we have what I would consider really the infrastructure for digital libraries as we know it today. Here we have this man over here. Some of you might recognize former vice president, politician, Senator Al Gore. He has been ridiculed for saying that he invented the World Wide Web and that people say he didn't. Well, they're kind of both right. No, he did not invent the technology for World Wide Web. He's not a scientist. He's a politician, probably a lawyer. But he did create the bill, so-called Gore bill, that allowed for the World Wide Web to happen. A lot of legal things that had to happen. It wasn't all just technology. You can see it's an act, but it basically allowing all sorts of laws and things for like private companies to get involved and all this sort of stuff that I don't really understand a lot about because it's sort of legal things, but he set that up for it to be voted on and become law so that the World Wide Web could come along. And then we have this individual from Britain, Tim Berners-Lee, and he, while this law was being developed, and I'm sure before it, come up with something called hypertext markup language, and then also this idea of the World Wide Web and the hosts and servers and how client and server would work and all that jazz. And basically, pretty much these two individuals developed the law that allowed for the World Wide Web, and then Tim Berners-Lee the technology to make it happen. HTML is very easy. I don't get into this too much. I do talk about it a lot more in the XML class, but HTML basically was a very easy way to build websites. It made it so, if we go back, to do SGML and to do sort of markup type languages pre-World Wide Web, you had to be an expert. You really had to know what you're doing. It wasn't very easy. Whereas HTML, I could take any of you, if you don't know HTML, pretty much within 20 minutes I could have you set up so you're building your own websites. Very easy. In some ways too easy. We'll talk about that a little bit later in the class, but HTML is allowed for a lot of poorly marked up websites that have not aged very well over the years. We have some other technology that we'll come back and talk about a little later on. Again, I'm not going to hit you too hard in the class with technology because this is not a programming class per se, but you do need to be aware of it. Various database and web server technology all got developed as this World Wide Web came into existence. Various database type software, web server software, that sort of thing to basically make a digital library infrastructure possible. The advent of, we've had programming languages around for a long time. I'm not going to mention the older ones, but we have ones that are still in use that are older than me, from the 50s and 60s, Fortran, COBOL. But those are the languages sort of old. They're still very useful in certain contexts, but if you're going to learn programming, that's not what you would learn. Most likely you would learn some kind of web programming language. Java is still used a lot, although it's starting to show its age, but PHP, Ruby, these so-called scripting languages. JavaScript has really taken off now. It used to be kind of sort of a pain to use, and now it's become, people are making their entire living doing nothing but JavaScript. HTML and XML, and then we have these frameworks. Again, I'm not going to get into it too much, but web development has become a very complex environment and job to do. We have other developments that came along that allowed us to take the analog world and get that onto some kind of digital format, whether it be in a computer or on some kind of piece of media. But flatbed scanner was developed. Again, Xerox PARC strikes again. Xerox PARC is in Palo Alto, just so you know, just outside of San Francisco. Again, very close to Stanford, not to mention all the other major IT companies out there. Digital camera, invented, again, the irony of ironies, by Kodak, and digital is what eventually put Kodak out of business. Compact disc and laser disc, 1970s, those technologies, they seem, particularly compact disc, you think of 80s and 90s, but really it's been around since the 70s. The MPEG, this is the music and audio and video format, digital format, 93. Flatbed scanner, Ray Kurzweil Very famous man that right now is getting into some pretty heavy stuff if you look him up on the web in terms of the idea of singularity and the future of like people living in basically in servers and things like that. It's stuff that's beyond me, but look him up. He's very interesting, a very smart individual. Has invented a lot, did a lot in the music world. Not to mention flatbed scanners, but also optical character recognition, which we'll talk when we get to digital text. We'll talk about OCR. Again, Ray Kurzweil, very old technology here. This is already decades old, but still very important to what we do in digital libraries. Early digital libraries. Okay, so finally, pre-World Wide Web, 1971, but digital library nonetheless. This Project Gutenberg, it's still going. It's out on the web. I think it might be hosted by the Internet Archive now, but I can't. You have to look that up. I can't remember. But single-handedly, almost by Michael Hart, did it for years as like kind of a part-time thing that he did while he was at university. Was scanning things like Shakespeare's sonnets and that sort of thing. And then got other volunteers to get involved, but I don't know if he ever made a cent off Project Gutenberg, but he felt like we have the technology and he had the skills. Why not do it? Brewster Cayley, Internet Archive, 1996, still with us. Huge player in the digital library world. When I say digital library, we use it loosely, but Internet Archive is so big that it's called a digital library is almost kind of a misnomer because it's like hundreds of digital libraries in one big one. The Wayback Machine, again, Brewster Cayley, kind of a separate project, but it's all right at the Internet Archive, but basically a way to preserve websites that have been taken down. The University of Albany website, if you want to go to the Wayback Machine, you can look up albany.edu and go back to 2001 or 1999 to see what the website looked like then. So it's archiving basically the entire World Wide Web, taking what we call screenshots, if you will. Some of it has some functionality, some of it doesn't. If you click on a link, it might work. If it hits a database, it might come up with nothing, but still a great project. Internet Archive, I didn't really mention what they actually do, but they have all sorts of projects of video, audio. You can upload your own things. They have people there that are going out and curating digital materials, all sorts of neat stuff that's in there. Making of America was one of the first sort of academic projects that was actually funded by a traditional funding source like like the not the NSF, but say like NEH, National Endowment for the Humanities, that sort of thing, where that's what we do today. We often get public funding. They had materials that were digitized or they digitized for the project and put it in this Making of America. So lots of text, but a lot of images and some video and audio. That was still kind of early on in the video audio part. And then we have the Library of Congress. Probably the sort of the mother of all libraries in the U.S., along with the New York Public Library and some of the bigger universities. But again, they've been a big leader in the digital library sort of world. And then we had the National Digital Library Program, which funded stuff they did internally, but also set standards and funded external projects. Hathi Trust is much more recent. Salman Rushdie was sort of like made a big splash like in the New York Times and places like that because it was the first digital library where they really tried to take someone's life and their work and actually recreate it in a digital library. So for example, when you got on this digital library, you actually had to go to the physical space and use it, and it was an emulated where they basically copied an old Apple IIe. I don't know what it was. There's multiple Apples, but an Apple operating system, and made it so you could see exactly what Salman Rushdie saw when he was, looking at his documents. They were rendered perfectly as they were in, say, 1993 using 2008 technology. We'll talk a little bit about emulation later in the course when we talk about preservation, but it's sort of an advanced topic. But anyways, it was a notable digital library, kind of recent. Million Book Project, Carnegie Mellon. The Google Book Project, which I think is pretty much dead now. Google has gotten out of doing Google Books. That was a huge scanning project where they got involved with multiple universities and public libraries. They did Harvard, New York Public Library, I think Michigan, maybe Boston University. But one of their big problems is they just ran into a lot of copyright issues, and we do talk about that some in the class, but that's almost can be a whole course unto itself. But we do need to talk about it a little bit because copyright's always an issue when you know that essentially right in your mouse is a way that you can just copy something. You can highlight it, copy it, and paste it, and really copying is that easy in the digital world. So copyright is always an issue. DPLA 2013, Digital Public Library of America, that's taken off and seems to still be going really strong. And probably the biggest and most recent digital library development right now. Little glance here, technologies and standards, Dublin Core. We're talking about standards, we're talking about metadata standards, basically a way to, in a standardized sort of way, a community, library community accepted, standardized sort of way to mark up digital material, whether it be audio, video, images, text, books, anything digital, newspapers. Dublin Core was a first stab at that. We have encoded archival description, EAD, something I use in my profession to mark up finding aids. TEI, Text Encoding Initiative, big in the humanities, particularly literature world. METS was sort of like, no pun here, but kind of a metadata standard. It was a way to wrap up a lot of, if you had a sort of a digital object like that had multiple pieces to it, say a book that has many scanned pages in it or newspaper, METS was a way to make it all into one piece, whether it be, you know, one object and so forth. And we'll talk about that later on. Then we get into these other metadata standards that really are, again, like administrative type metadata standards that sort of have facilitated the digital library world. Here's one that's for preservation. Mark XML, not so recent. That was like basically an XML implementation of Mark. But again, lots of technologies and standards. It's just a few of them at a glance. The Open Archives Initiative, that was another technology that sort of facilitated a lot of work with digital journals. OAI PMH was an extension of OAI that basically made it so you could harvest the metadata from journals and various documents. OI STIR or Oyster at Michigan, now at OCLC. We'll look at that on the syllabus. But another way to basically be like a meta digital library that would link out to various repositories. You'd say look up some. We'll talk about that a little bit because I'm going to show you an example of that. DSpace, an institutional library software that was developed at MIT, and ViewFind, that is basically a search layer that libraries could use, again, to facilitate digital libraries. I think developed at Vanderbilt. I can't remember. I thought it was here in New York State somewhere. But anyways, an open source, both of these open source. So just to back up a little bit, we're winding down this presentation. You look at curators or digital librarians, if you will, in the analog world. Here's a lot of things they did. You have some, like anthropology or biology curators. Here you have a film curator. That'd be really cold. You got to keep film on its side so it doesn't, and keep it cold so it doesn't start to smell like vinegar. And then here you have a sort of rare books librarian, if you will, or curator. I don't have any pictures of digital curators, but here's a little definition, and what I wanted to leave you with is that we're going to talk about digital libraries. It's the name of the course, so I tend to speak using digital library or digital librarians. But you have to remember there's across the board in the you know, in the information manager world, anyone who's doing digital stuff often is doing digital library work, but they may not be called it. They could be called a digital curator. They could be just an archivist that also does digital library work. They could be a librarian. They might have the title Librarian 1, and they're using a digital library. Scientists, historians, there's data curators. There's all sorts of names for the work that we do. And so I'm just trying to present you with a little bit of a sort of a definition here to think of like digital librarianship or digital curation, digital curator. And here's one last sort of list of things that I've already started to enumerate some of them, but we have digital archivist in my field where I work in archives, but we also have electronic records or record archivist. That's kind of an older term that was used in the archives field, and again, that electronic word's starting to kind of go away, but that was the language that was used, the vernacular, I guess, of the profession then, and it's kind of going away. A metadata specialist, that sort of replaced cataloger, but either one of these may do print-based cataloging, or they most likely are doing something digital related. Again, librarian, systems librarian, web developer, data curation, and so on. So let's not get hung up on one term, but I will often use digital libraries, digital librarianship as sort of a catch-all for any kind of digital knowledge, digital information that's stored you know, on the web. So that's it for that video. Stay tuned for the next one.